Internal combustion engine operating on fossil fuel release carbon dioxide, contributing to global climate change. In order to eliminate those emission gases as well as decrease the potential of global warming, there is a need for an alternative energy source to replace this non-renewable source with a greener alternative. A fuel cell generates power cleanly and efficiently by using the chemical energy of hydrogen. Fuel cells can be used to provide power for a variety of applications, including portable, transportation, and stationary. Since hydrogen fuel cells release only water and no carbon dioxide, they can effectively solve serious climate change issues. Hydrogen fuel cells, especially proton exchange membrane fuel cells, have been proven to be promising energy conversion system for automotive application. Their key advantages are high efficiency, high current density, fast startup, low operating temperature, and produce more output power for a given volume and weight. Despite their relatively low heat generation and low operating temperature, Pemfc requires a relatively large radiator in their cooling system, which is unfavorable in automotive applications. Nanofluids have attracted great interest as a coolant due to their superior heat transfer properties. Nanofluids is a combination of solid nanoparticles less than 100 nanometer with base fluids such as water, ethylene glycol, or bioglycol. Nanofluid act as increasing thermal conductivity. The results show that the thermal conductivity of a suspension of nanofluids is significantly higher than that of the equivalent fluids. In this study, the experiment will be conducted to observe the thermal characteristic performance for Pemfc by using nanofluids as a cooling option. The study will base fluid water, ethylene glycol with ratio of 60-40 and 2 nanoparticles, Al2O3 and SiO2. The hybrid of nanoparticles between Al2O3 and SiO2 with ratio of 10-90, 30-70, 50-50 and 70-30 also been observed. The experiment set up with 0.5% concentration of nanoparticles and the operating temperature of the channel is set at 60 and 70 degrees Celsius. Fuel cell is an electrochemical energy conversion device that was invented in 1839 by William Grove to produce electricity by combining hydrogen and oxygen into water. Similar to batteries, fuel cells turn chemical potential energy into electrical energy with the byproduct of producing heat. Vehicle and electrical gadgets such as portable computers, mobile phones, and communication devices are the application of fuel cell. Proton exchange membrane fuel cell, also called the polymer electrolyte membrane fuel cell, solid polymer electrolyte fuel cell, and solid polymer fuel cell, is the most widely known version of acid fuel cell. From study by M.R. Islam, Pemfc produce power at efficiency range of 40 to 50% greater compared to internal combustion engine, which has an average efficiency of 20%. A proton exchange membrane fuel cell converts the chemical energy released during the electrochemical reaction of hydrogen and oxygen into electrical energy as opposed to directly combustion hydrogen and oxygen gases to produce thermal energy. The term nanofluid refers to a fluid in which nanoparticles suspended in the base fluid form a colloidal solution. The base fluids used in nanofluids are typical water, ethylene glycol, and oil. The nanoparticles used in nanofluids are generally metal oxides, carbon nanotubes, and carbides. According to Ahmad, using nanofluids increase the thermal conductivity and conductive heat transfer coefficient compared to the base fluids. Nanofluids have novel properties that make them potentially useful in many applications in heat transfer, including fuel cell and hybrid power engine cooling, vehicle thermal management, and heat exchanger. Nanofluids may offer promising solution to help reduce the size of thermal management part of Pemfc system. The thermal management of the Pemfc is a critical requirement for optimal power generation and the highest level of performance. According to M.R. Islam studies, a nanofluid coolant in Pemfc can reduce the size of the radiator needed to dissipate its thermal load and eliminate the need for deionizing filter and lower the freezing point of the base fluid. According to IRNIE ZAKARIA, The highest thermal conductivity is measured at base fluid with 0% concentration of ethylene glycol. Meanwhile, the pure ethylene glycol gives the lowest thermal conductivity as a base fluid. This study summarized that the thermal conductivity decreased with increasing ethylene glycol, and thermal conductivity also observed to increase as a function of volume concentration as expected. Based on Seshu-Kumar-Wadrangi, 40 ethylene glycol and 60 water-based nanofluids large coefficient of heat transfer outperform in the case of 60 ethylene glycol, 40 water-based nanofluids. Heat transfer of Al2O3 was also observed, and it's also outperforming SiO2-based nanofluids at the same level of volume concentration. The result of the study shows that Al2O3 with 40 ethylene glycol, 60 water nanofluids tend to be associated with significant heat transfer coefficient. From study by Muhammad Shafiq Idris, using nanofluids in cooling plate of PMFC, the ratio of 1090 of Al2O3 SiO2 hybrid nanofluids was an advantageous absorption in PMFC. The highest enhancement was given by the hybrid 1090 of Al2O3 SiO2 with 5.52% enhancement as compared to the base fluid of water. The result also can be observed by study from Saifuddin Khalid, shows that the maximum value of thermal conductivity was recorded at the ratio of 1090 Al2O3 SiO2 at 80 degrees Celsius with 51.9% enhancement compared to its base fluid of water. This paper summarized that 1090 ratio of Al2O3 SiO2 hybrid is the most feasible ratio for the implementation in PMFC. Ethylene glycol, EG, is an organic compound with the formula of CH2OOH2. It has low freezing point, approximately -12 degrees Celsius, and high boiling point, better stability over a wide range of temperatures, and good thermophysical properties, which makes it appropriate for use in temperature range where the possibility of water freezing exists. EG is used as a heat transfer fluid in a system such as a car radiator, solar and geothermal technology. However, there are some side effects of using ethylene glycol. Ethylene glycol degrades into harmful chemicals in the body. Ethylene glycol and its poisonous derivatives initially attack the central nervous system, then the heart, and eventually the kidneys. Based on studies by N.A. Usri, pure ethylene glycol has lower thermal conductivity compared to pure water. However, EG has greater properties in terms of boiling point, therefore EG can absorb heat at higher temperature than pure water. Nanoparticle aluminium oxide Al2O3 and silicon oxide SiO2 was added to overcome the disadvantages of EG. There are three objectives of this study. First, to investigate the performance of hybrid nanofluids of Al2O3 and water ethylene glycol in an electrified electric channel. Second, to investigate the thermal performance of heat transfer and pressure drop of hybrid nanofluids ethylene glycol in an electrified channel. And the last one is to investigate experimentally both single and hybrid nanofluids in an active electrical single cooling channel in terms of electrical drop due to conductive property of nanofluids. The study might have some limitation as this experiment is only focusing on water ethylene glycol with ratio of 60-40 only. This experimental study is only part of the PMFC due to cooling channel was not the real application for PMFC. Lastly, this experimental only studies which nanofluids is suitable to use in real application of PMFC. The early phase of the study focusing on collecting articles and journals related to nanofluids in PMFC. The articles and journals comprise with the past research and experimental of the study topic. The research for the literature review had been done and valuable information has been summarized in the table. The phase 2 conduct with preparation of nanofluids. The nanofluids used in this study are water and ethylene glycol in 60-40 ratio. Meanwhile, the nanoparticles are made of aluminium oxide powder Al2O3, silicon oxide dispersion SiO2, and a hybrid of the two. The ratio of the hybrid that has been observed is 10-90, 30-70, 50-50, and 70-30. The experiment will be conducted at UiTM. The collected data will be analysed, then further calculation and comparison of each nanofluids are made. For the last phase is writing the full research and experimental report and made a discussion and conclusion from the finding based on the data analysis from the experiment. The figure shown is the experimental setup. The component in this experiment contains power supply, thermostat, flow meter, radiator, reservoir tank, pump, cooling channel, data logger, digital meter, and lastly, voltage regulator. The expected from this experiment by using mixture of 60-40 water ethylene glycol can improve in terms of heat transfer coefficient compared to by using 100% distilled water. The thermal conductivity is expected to have a higher volume. Meanwhile, for electrical conductivity, it is expected to have a lower value. For the pressure drop, it is anticipated to have lower value to have a better performance of electrical single cooling channel. In terms of using various hybrid of nanoparticle, Al2O3, SiO2, we expected that the ratio of 1090 hybrids nanofluids is the most practical to be used in Pemfc. By the end of the experiment, we can make a comparison between every hybrid nanofluids and can make a conclusion based on the result obtained.